Hello, and welcome to this Altech Corporation webinar. My name is Matthew, and I will be your Global Spec moderator, and I want to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's session. Just to the right of the main presentation window is the Speaker Bio window with background information on today's presenter. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed into the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now let me introduce today's presenter. With us today is Morgan Early, the Product Manager with Altech Corporation. To read more about Morgan, please look at the Speaker Bio window right next to the main presentation window. Morgan, welcome to today's event, and with that, I will pass things along to you to get started.
Thanks for the introduction, Matt. Hi, everyone. I am one of the product managers at Altech Corporation in Flemington, New Jersey. Since 1984, Altech Corporation has been an established United States supplier of components and devices used in industrial control, instrumentation, medical, and automation applications. Altech offers a broad line of products, including control panel components, circuit breakers, disconnects, contactors, enclosures, and safety devices. We are known for supplying high-quality products at great prices. We offer products under our Altech brand name, and we represent several companies from around the world whose products we sell under their brand names. Our company's heritage and many of the products that we supply are from Germany. Most of the safety standards that we use today originated in Europe, particularly in Germany, so safety products are a natural addition to our line since we deal with so many German high-tech manufacturers. I originally started working with safety products about 30 years ago when no one knew what a safety relay was. In those days, it was common practice to run the machine's power directly through the safety switches for smaller machines, or use the safety switches in line with the coil voltage to a master control relay. It worked, but there was no way to detect if the contacts in the safety switch or the master control relay were welded or broken, or if there was a short in the wiring. The only way you found out was when you opened the door or you hit the e-stop button and the machine kept running. A truly safe safety system needs to be control reliable, or fail-safe for lack of a better term. According to the standards, this means you need to create a circuit which does not rely on a single component to ensure the correct function of the safety system. Control reliability implies that a device or system is designed, constructed, and installed so that the failure of a single component within the device or system shall not necessarily stop the machine immediately, but shall prevent a successive machine cycle from taking place. You can fix some of this by adding a redundant safety circuit, which means adding redundant contacts to your safety devices. This addresses some of the issues, but it doesn't provide a complete solution. According to the standards, even when redundant components are used, the failure of one of the components will cause the machine to revert back to its original dangerous condition. In order to prevent this, both the circuits and components should be monitored. If the failure of one of the components is detected, it is not necessary to stop the machine immediately, but it should prevent a successive machine cycle from taking place. The easiest way to monitor the circuits and components is to use a safety relay in place of the master control relay. The safety relay checks continuity of both safety circuits, and if both circuits are closed, provides one or more closed outputs. Some also check for polarity to ensure that there's no cross-wiring. Detection of cross-polarity or one open safety channel will cause the safety relay outputs to immediately open. An optional reset button can be used for restart, or the relay can be wired for auto restart, which provides closed outputs whenever both safety channels are closed. If the continuity of either of the safety channels is broken, by opening a door or pressing an e-stop button as an example, the safety circuit outputs will open immediately. The continuity to both safety channels must be restored and the reset button pressed for manual reset versions for the output contacts to close. The safety relay monitors both channels for simultaneous operation as a way to check that the safety devices are working properly. If both safety channels do not change state within half a second of each other, or if only one channel is detected, the safety relay will go into fault mode, requiring recycling of the safety device or repowering the relay before it can be restarted. By adding a redundant circuit and monitoring it with a safety relay, we now have a safe, control reliable safety circuit, which manufacturers have been using for years. But then a problem was found. Let's go back and look at our redundant monitored safety circuit. Here both doors are open, so the machine cannot be started. If both doors are closed and the reset button is pressed for manual reset versions, the machine will start. If a fault develops on one of the safety device contacts or the wiring, the machine will keep running with its doors closed. The fault will prevent the machine from restarting even after the door is closed. To start the machine, the fault must be corrected and the safety device must be recycled or the safety relay must be repowered. Even if the door with the fault is closed, the safety relay is still in fault mode and the machine cannot be started. However, if that door is closed and another door is open and closed, the safety relay will interpret that as an indication that the fault has been corrected. This would reset the safety relay and allow the machine to be restarted, even though the original fault condition still exists. This could eventually lead to a double fault, which would allow the door or panel to be opened when the machine is running in a dangerous state. This problem is called fault masking. Here's how Bernstein explains it.
In machine safety, fault masking is often an underestimated problem. Safety guards of machines are often protected by electromechanical safety switches. If there are several doors, they are usually connected in series and connected to a safety relay. Series connections of electromechanical contacts create a problem. Imagine a wiring error occurs in one switch. After activating the switch, the machine can't be started again. So far, so good. But if then another switch is activated, this fault is overwritten. Due to this fault masking, a second wiring error will also not be recognized, which leads ultimately to a dangerous situation for the machine operator. A problem that Bernstein eliminates with its smart safety sensor, SRF. The SRF is the electronic solution with self-monitoring electronic outputs. The SRF sensors recognize at all times if there is a wiring error or not. If an error occurs, they switch off the system in a controlled manner. This is the main advantage of the electronic SRF safety sensor. Thanks to SRF, the system cannot be restarted if a fault occurs. That's why it's called smart. That's why it switches safely, even in a series connection. With the smart safety sensor from Bernstein, the problem of fault masking is a thing of the past.
Here's another video from Bernstein, which explains how to alleviate this problem using our SRF non-contact switches. And since safety devices include e-stop buttons, here's a video on how to easily integrate an e-stop module into our OSSD system.
Where to connect the emergency stop device. In accordance with the machinery directive, each machine has to be equipped with at least one emergency stop device. These emergency stop devices are typically equipped with electromechanical contacts. If these are now connected in series with other electromechanical safety switches, the possibility of fault masking arises once again. To solve this problem, Bernstein offers an electronic emergency stop device, specially adapted to the SRF safety sensors. This electronic emergency stop device fits perfectly into the SRF series. Simply integrate it via the M12 connector and that's it. And despite a series connection, you no longer have to worry about fault masking. In addition, the electronics allow the transmission of extensive diagnostic data so that your machine can work very efficiently. This creates the basis for predictive maintenance. SRF and SEU. With Bernstein, your machines will be Industry 4.0 ready.
Here's one last video which goes into some more detail about the diagnostics and the new Bernstein Safety PLC.
You probably know this well. A machine needs to be safeguarded, in this case with only one single safety guard. For this simple installation, a safety switch connected to a safety relay is mostly sufficient. Typical installation. Typical problem. If the guard drops, the actuator will likely break. It could be much simpler with the non-contact safety sensor SRF from Bernstein. And what if more guards need to be safeguarded? Then more SRF safety sensors will be connected in series. If one guard drops now, the corresponding SRF sensor will send diagnostic data to the safety relay. But this DCD data cannot be processed by the safety relay. Therefore, a Bernstein diagnostic module will be connected that can transmit the DCD signal via an I/O link gateway. This installation is already much more complex. And the emergency stop device? The machinery directive requires at least one e-stop device. How to connect this into the existing safety chain? The simple answer, not at all. Install a second safety relay, wire it up, and you're done. Easy to do, but complex, and not really smart. Integration into the existing safety chain would be smarter. But what e-stop device would allow that? The Electronic Emergency Stop SEU. This can simply be integrated into the chain as a further component of the smart safety system from Bernstein. Together with the SRF safety sensor, it provides a smart solution. Like the safety relay SCRDI. This combines a safety relay and an I/O link diagnostic interface in one device. A smart solution for your safety chain, with only a few, but smart components. That's all very well, but what about more complex systems? Even then, you don't need to buy different safety relays. The safety relay SCRP can monitor different independent safety chains. With this device, you can simply access up to 64 smart devices. Smart. That also applies to the software. Even complex safety systems can be quickly configured via drag and drop. And all information and daisy chain diagnostic data are available regardless of where and how you need them. A clever solution with comprehensive diagnostic data for your safety application. Smart Safety System, powered by Bernstein.
Bernstein's Smart Safety System addresses the situation by wiring the network in a different way. Instead of wiring all the safety devices in a series circuit, the Bernstein Smart Safety System uses a cascading system. When the first sensor is closed, it communicates to the next sensor downstream. The next sensor checks to make sure it has received a signal from the first sensor, and that is closed. And then it communicates that information to the next sensor downstream, and it continues down the line. This cascading chain can be extended for up to 32 sensors. Instead of 24-volt DC signals, the Bernstein Smart Safety System uses two OSSD outputs, which stands for Optical Signaling Switching Devices. These are pulse signals, which the safety device checks to create a further level of monitoring. Our Smart Safety System features an M12 connection system, which provides plug-in installation convenience, saving time, wiring errors, and labor. Individual sensors are connected to a series line using T-connectors. The series line uses a 4-wire cable, offering an additional cost savings. The safety relay is the only thing that needs to be manually connected, and that only takes 4 wires, OSSD1, OSSD2, positive and negative. All versions of the Smart Safety System include either PNP or daisy chain diagnostics, which are designed to provide status indication to the machine's control system and aid in troubleshooting. This is separate from the safety outputs. PNP is the simplest type, providing a PNP output when the door is open. These outputs are designed to provide inputs to the machine's control system to help control its operation in addition to the safety relay shutdown. Some systems are available with an integrated bus system, which we call the Daisy Chain Diagnostic System, or DCD. The bus system carries 24 different types of information from each sensor. This can be run into a diagnostics module, where it can be read by a PC via I/O link, or a PC using a USB cable. Sensor status can be read locally with an Android-based smartphone or tablet using NFC, which is near-field communication. Both Android NFC and the PC software are available for download at no additional charge. The most popular sensor that we offer with the Smart Safety System is our SRF non-contact safety switch. These feature RFID communications, Category 4 PLE SIL3 safety ratings, a protection class of IP69, low, high, or unique coding, easy code teach-in, LED diagnostics, fault-tolerant outputs, with options including local reset, PNP, daisy chain, I/O link diagnostics, and Android NFC smartphone monitoring. These are designed to replace keyed safety door switches, which can have problems with alignment. We offer several different emergency stop button options, all with OSSD outputs. These devices feature M12 plug-in connection, twist reset, built-in LED status indication, and optional DCD diagnostics. The diagnostics information can be used to determine which device caused the shutdown of the machine. Our system can also be used with standard dry contact safety devices. We offer a transition box, which will convert dry contact outputs into OSSD outputs. Standard components and limit switches are available with M12 connectors to allow for plug-in installation. Whether you're interested in preventing fault masking, or you would like to add a higher level of diagnostics to improve factory automation and communication, or you just need a dependable, easy-to-use, plug-and-play safety network, our Smart Safety System can answer your needs. Thank you for joining us today.
Thank you so much for that great presentation. And now let's get to the Q&A. We have some questions that have come in from the attendees, so we're going to move into answering those right now. If we don't get to your question, don't worry, we will have an answer for you following the webinar. If you haven't submitted your question yet, you can still do so now by entering it in the Q&A box and clicking Submit. And we'll try to get to it before the close of the session. Okay, now for our first question from the audience. What is the main benefit to using the Smart Safety System? Morgan?
Hi, Matt. Well, Really, it depends on your application. People have different priorities as far as what's important to them. From my standpoint, I think one of the nicest features of this system is it's all plug and play. It's all M12 connectors. The only wiring is back to the safety relay itself, or whatever diagnostics relay you're going to use, and everything else just plugs together. There's no wiring at the individual components. You just plug it in. If you need to add components or minus components, all you do is plug and unplug. You don't have to address the individual modules or anything like that. It's just strictly a hardware function. So the idea of having a completely plug-and-play system is very nice, as far as I'm concerned anyway. But, the other benefits are certainly important. A lot of people are concerned with diagnostics. They're trying to get into more factory automation aspects, and that's an important function too. And then communication in general is very simple with this system. And the units themselves have individual functions as far as their main benefits are concerned too. So there's a lot of benefits to the system, but for me, having wired up a bunch of safety components in the past and gotten very few correct the first time, the idea of an M12 plug-in connection is very nice.
Very cool. Thank you for that. Yeah, I always say simple solutions for complex problems. Sounds like you're right on the money with that. That's great. Okay, moving along to the next question from the audience. What is the lead time for these products?
Well, we keep a lot of stock in our facility at Flemington, New Jersey, and several of our distributors are stocking throughout the United States. So typically, these are stocked products in the States. Worst case, if none of us have stock here, we can get it directly from Bernstein. Worst case lead time from Bernstein is usually 6 to 8 weeks, but for the most part, this is a popular product for them, so they keep pretty good stocks too. One of the other nice things is that I can tell exactly what Bernstein has in stock. So, I can let you know immediately if there's going to be any lead time issues and how quickly we can get it in. But as I say, for the most part, they're stocked at either our facilities or our distributors.
Excellent. Thank you for that. Excuse me. And I'd just like to remind the audience, we are now in the Q&A session. We have our experts from Altech Corporation online and ready to answer you, so please send us your questions. You can do so now by entering it in the Q&A box and clicking Submit. In addition, while we review all these wonderful questions that are arriving, I'd just like to point out on your screen in the top right corner, there is a PDF copy of the slide presentation. So we received a few questions, whether or not you can download the slides. Yes, you can. You can access it now in the top right corner. Okay, back to the questions. Next question from the audience. Can you help specify the components for the system?
Oh, sure. That's certainly something we're very happy to help with. We just need some kind of a rough drawing of what your application is, what components you need, where, and the lengths in between, and we can work up a bill of material list for you. No problem there.
Excellent. Thank you. And next question. How do I pair the RFID non-contact switch sender and receiver?
Okay, that's a good question. There are several different levels of coding between the non-contact switches. We have low level, high level, and uniquely coded. But they're all taught in the same way. Basically, in order to teach them the sender and receiver together is you just literally mate them together, give them power, turn the power off. They're temporarily taught at that point, and you repeat the process. Just give it power one more time and turn the power off, and then they're permanently taught in. So it's a very simple process.
Excellent, thank you. And we're getting a lot of great questions. If you want to turn your attention to that one that just came in on the bottom, be a moment there. And as we take a look at the question list, I just want to remind the audience that the entire session today, the presentation, including this Q&A session, will be available for replay beginning tomorrow. So please feel free to come back and watch this again. Okay, and let's see, next question. Okay, here it is. What is the activation distance of the RFID non-contact switches?
It's about a half an inch. The actual activation distance is anywhere between 10 to 13 millimeters. So it's got enough room where it's got some play, so you don't have to worry about alignment like you would with a keyed switch, but it's also tight enough where nothing's going to get in around it. So that's an important feature too. Now, in addition, something we didn't really talk about, the switch actually in the diagnostics will give you a warning of when it's about to switch. When they start to separate, it'll give you a warning of just about there when we're going to switch, and then it'll actually switch. So there is actually a function in the diagnostics that tells you when they're about to switch or when they're close to opening.
Excellent. Thank you for that. And okay, next question here. So as it reads, do what if I don't need diagnostics?
Oh, okay. So I'm assuming that's just, what happens if I don't use the diagnostics?
What do you do if you don't have them? Right. Yep. Mm-hmm.
Right. Exactly. So the diagnostics are a completely separate system. So you don't have to use them. There's no need to hook up to either the PNP or the daisy chain. You can run it without diagnostics as a separate standalone safety system with no problem at all. You just don't hook it up to any kind of interpretation module.
Excellent. Thank you for that. And like we have one or two more here. So here's the next one. How can I interface the diagnostics into my control systems?
Well, the system itself features an I/O link as far as the daisy chain is concerned, so that you can run into either I/O link directly, or you can bridge out to any number of bus systems from there. It also has a USB interface that you can run directly into a PC, or the other system is near field communication, which is basically, it's some of the smartphones and some tablets have this feature where you can walk up to the sensor and put it on the module and read exactly what's happening on your network through your smartphone or through your tablet. And then, of course, the simpler system is PNP, which is a direct wire, and you can run up to 16 outputs through your PNP output directly into your PC, or directly into your PLC. So you have a number of different options as far as how you're hooking it up to the control system.
Great stuff. Thank you. And I'd just like to remind the audience, we are in the Q&A session. If you have any last questions, please send them in now, and we'll try to answer. We'll just give it a moment here to see if anything comes in. Okay, it looks like that was our last question. So we're going to move to wrap things up. Was there one more that came? I see it on the bottom. Yeah. Let me slide that one in, no problem. Okay, here we go. All right, so here's our last question for now, unless anyone else sent us anything in the meantime. Here it is. How fast would you say standards related to machine safety are evolving, and therefore product must evolve as well? Will personal transportation devices fall into the same safety standards, or will there be new standards from the automotive domain?
Okay, as far as the safety standards themselves, they're not real fast to evolve because they've been in play for so long. There were a few different generations. The first generation, as I talked about in the beginning of the presentation, was just switching over to a safety relay and running, dual safety circuits. And then more recently, I'm talking within the past maybe 3 or 4 years, there's been a lot more solid state devices brought into safety. So it was necessary to redo some of those standards, and that's where the new systems have come out as far as the PLE, the performance level systems. Those are looking more at mean time to failure of components and other solid state issues. So they get a little more complicated as far as rating your safety system. But that was one of the biggest ones that I've seen in literally 30 years. And an offshoot of that is this OSSD instead of running to with dry contacts. And that, so really you're looking at, over a period of 30 years, you're looking at 2.5 major changes. So they are slow to evolve. As far as the question on personal transport devices, I'd have to check into that. There are C standards, which are basically standard. There are general standards, and then there are specific standards for applications, and that would fall under one of the C standards. So we'd have to look at what the C standards say about that. But I can certainly do some research on that and get back to you.
Excellent. Thank you for that. And we did have one more question that popped up. Here it is. How do I download the software?
Oh, okay. That's easy. Bernstein's website has all the software available at no charge. Very easy to go in there. You just go to the download section, and you can download the Diagnostics software right onto your computer. Or you can actually go in and go into the Google Play, I believe it is, for your phone. The near field communication system does not work with Apple yet. It only works with Android systems. So that's one downside. They are working with it, and they tell me that it's going to be available shortly. But for right now, it's only available for Android. That's available at your Android PlayStation. So.
Excellent. Okay. Let's see if there's anything left. I think that was the last question. So we are going to move to close. Morgan, thank you so much for the great presentation and also answering some audience questions today. I'd like to also thank our audience members for being part of this webinar event. As mentioned, you will be receiving an email from us with a link to the on-demand version of this presentation, so you can come back and watch it again or share it with your colleagues. And lastly, please take a moment to complete a survey which will appear on your screen at the end of this live webinar. For on-demand viewers, you will find the survey located along the bottom of your attendee console in the survey widget. Again, thank you for taking the time to attend this webinar event. Take care, and we'll talk with you soon.